Hello students and welcome to my channel Maths Hub. So today in this video, I'll tell you how to find the inverse of a matrix using the row transformations. Already one method you know that you do it in plus 2. That is the method where you calculate the adjoint, and so we are not going to use that method. We will be using the row transformations to calculate the inverse of a matrix. So let us understand the technique. So what is the algorithm? The algorithm says you need to write matrix A as I into A, right? So I is the identity matrix. So A, it is always a square matrix, only then we have to calculate the inverse, and it is understood that the determinant of this matrix is non-zero, that it is a non-singular matrix. So for a non-singular matrix, we have to calculate the inverse and we write it as I into A, right? Now, we will start applying the row transformations on the left hand side of this equation, that is on this matrix. And whatever operation we apply on the left hand, we will apply the same operation on the identity matrix, right? We won't write anything on this A. So what will happen? We start with A is equal to IA. We start applying row transformations here on A matrix, and we apply the same row transformations on the I matrix, right? And by applying the row transformations, what we need to achieve, after certain steps, we need to make this A into I, right? So after some finite number of steps, when A converts into I, obviously I will not remain same, it will get converted to some matrix B, and we have A along with it, right? So whenever we have a product of matrix equal to I, that means this matrix must be the inverse of this matrix. So at this step, we will get the inverse of the matrix A, that is matrix B, right? So let us try to apply this in the questions and see how to get the inverse of a matrix. It's very simple method, right? So you should be clear when you are applying the row transformations. So the row transformation should not be wrong. So we need to calculate the inverse of 6554. So we start with the step, the basic step, that we put A is equal to I into A. So when we write A is equal to I into A, so we are given a 2 cross 2 matrix. So we write 6554 is equal to, so we will write an identity of order 2, that is 1001, and we'll write A along with it. We will not expand this A, right? Now we have to, our goal is to convert this matrix into an identity matrix. So the first transformation that I apply is, I have to make this leading element 1. So how will I make it 1? I can subtract the two rows. So I've written R1 is R1 minus R2. And when I write R1 is R1 minus R2, so we get 1154, and we apply the same transformation here. So you can see that 1 minus 0 is 1, 0 minus 1 is minus 1. So we get this step, right? Now, after this step, we have to make the element, that is 5, we have to make the 0. We have to make the element below the leading one equal to 0. So we apply the row transformation. R2 is equal to R2 minus 5 R1. And when we apply R2 is equal to R2 minus 5 R1, you can see that we get 1, 1. There is no change in the first row. The second row, it will become 5 minus 5 is 0. 4 minus 5 is minus 1. The same thing we apply here. So there is no change in the first row. Second row will become 0 minus 5 is minus 5. 1 minus minus 5 is 6. Right? So you can see that the first column has become identity, the desired 1, 0. Right? Now, what we need to do, we need to make in the next column, we need to make this 0 and we need to make this 1, right? So what we have done, we have applied R1 is equal to R1 plus R2. So to make this element 0, I can add the two rows. When we add the two rows, we get 1, 0, 0, minus 1. And when we add these two rows, we get these elements, minus 4, 5, minus 5, 6, multiplied with 8, right? And then we need to make this 1. So we have multiplied the second row with minus 1. So we apply the transformation. R2 is R2 minus 1 times R2. So the same operation applied on the right hand side. So we get 5 and minus 6. So this step is important. So at this step, you can see that we are getting identity matrix, we are getting a matrix that is -4, 5, 5 and -6, and we are getting the matrix multiplied with A. So A multiplied with some matrix is equal to identity. That means this matrix is definitely going to be the inverse of this, right? So A inverse becomes -4, 5, 5, minus. So I hope it is clear. So it's just a matter of transformations that you are applying. And while you are applying the transformations, you need to be very consistent. You will not make any mistakes. Otherwise, right inside the identity, when you are converting that into the inverse, error will be committed there also, right? Okay. So now let's move on to another question. So we have to apply the elementary row transformations to find the inverse of this matrix, right? So now whenever we are applying we are calculating the inverse, we have to always apply the row transformations. You cannot apply row and column both, right? So the first step is you'll write A as I into A. So we write A matrix on the left hand side. Now we are given a 3 cross 3 matrix. So we choose an identity of order 3 cross 3, right? Multiplied with A. So we don't have to expand the A on the right hand side, right? So the first step is we have to make the leading element 1. So what we can do, we can first multiply this row with 3 and then we can subtract it from R2. So that is what I've done. So we are multiplying row 1 with 3 times R1. So we get the entry 6, 0, minus 3, and samely we get the entries on the right hand side as 3, 0, 0. Then we apply the transformation R1 is R1 minus R2. So when we apply R1 is R1 minus R2, we get the leading element as 1, right? And subsequently, you can check these entries. We'll get -1, -3. And on the right hand side, we will get 3, -1, 0, right? Now, what next? We have to you can make this leading element 0 by multiplying the first row with 5 and then subtracting from it, right? So for now, we are adding the two rows because we have to make this element also 0, because in the next step, you should get the entries 0, 1, 0. So I can see we have -1, so we can add the two rows R1 and R3, so this element will become 0. So when we add R1 and R3 and make the change in R1, what do we get? We get the entry 1, 0, 0, and similarly we get the entry here 3, -1, 1. The rest of the two rows will remain same, right? Now we apply the next transformation and we make this element 0. How to make this element 0? We multiply R1 with 5 and we subtract it from R2. So we get the entries 1, 0, 0, 0, 1, 0 on the left hand side, and the same transformation is applied on this matrix and we get these entries, right? Next, we have to make this element 0 again, so we can subtract these two rows. So I can apply the transformation R3 is equal to R3 minus R2. So we get the next elements as 1, 0, 0, 0, 1, 0, 0, 0, 3. Similarly, on the right hand side, this matrix gets converted to 3, -1, 1, -15, 6, -5, 15, -6, 6 multiplied with 8. Then we have to make this element, the next leading element, as 1. So we can multiply this row with 1 by 3. So when we multiply this row with 1 by 3, we get 1 here. And similarly, these elements get reduced by 1 by 3. So we get 5, -2, 1, 2. So can you see that on the left hand side, we have got an identity matrix. So the matrix that is obtained here, this acts as the inverse of the matrix A. So A inverse turns out to be 3, -1, 1, -15, 6, -5, 5, -2, 1, right? So I hope the method is clear. So you can check out these exercises. I've given the answers. So try to calculate the inverse of these matrices using the row transformations, right? So you have 3 questions to do. So anyways, if you get stuck anywhere, you can just put it in the comment section and I can help you out, right? So if you like the video, do hit the like button. And those of you who have not subscribed my channel, do subscribe my channel and kindly share it with your known ones who want these videos, right? And believe in yourself and you will be able to succeed. Thank you.